So in this video we will discuss about the method 3. So to find an integrating factor of mdx plus ndy is equals to 0, if there exists a single variable function f of x such that dou m by dou y minus dou n by dou x divided by n that equals to the function f of x, then e power integral of f of x into dx is an integrating factor of mdx plus ndy is equals to 0. So here when the question is given, first we have to find out the dou m by dou y and dou n by dou x. Then if it is not exactly differential equation, then we have to proceed further. Then here first we find out the dou m by dou y minus dou n by dou x divided by n. So when we find out this, we will get some value in terms of x or in terms of y. So that function, if we get in terms of x, that is f of x, then we have to use the e power integral f of x dx as the integrating factor to the question. And for example, when we use dou n by dou x minus dou m by dou y and divided by m, then we get the function in terms of y, then that is called as the method 4. So in this method we find out the dou m by dou y and dou n by dou x with the minus of those differentiation and divided by the function n, then we get the function in terms of x, then we use this as the integrating factor. Let's solve few problems on this method. First question is solve 2xy dy minus of x square plus y square plus 1 into dx is equals to 0. So here it is in the form of mdx plus ndy is equals to 0, and m is minus of x square plus y square plus 1 and n is 2xy. So now differentiate the function m with respect to y, that is dou m by dou y that equals to dou by dou y of minus x square minus y square minus 1, and that equals to x square differentiation is 0 because you are differentiating with respect to y, and y square minus y square differentiation is minus 2y, and constant differentiation is always 0. So then that comes as minus 2y. Now differentiate the function n with respect to x, that gives us dou n by dou x that equals to dou by dou x of 2xy, and the 2xy differentiation is 2y. Then you can see here dou m by dou y is not equals to dou n by dou x. Then we can give a conclusion point as it is not exactly differential equation. So now we have to make it as exactly differential equation. So we consider the dou m by dou y minus dou n by dou x divided by n. Now dou m by dou y is minus 2y and minus of dou n by dou x is 2y, that is divided by the function n, that is 2xy. Now minus 2y gives us minus 4y and divided by 2xy, that equals to minus 2 by x. Now minus 2 by x is a function in terms of x, then we have to go with the method 3. If the result one is in the terms of y, then we have to go with the method 4. So at the time the function will be different. Then f of x is minus 2 by x, then the integrating factor will be e power integral f of x into dx is an integrating factor. So e power integral f of x into dx, that is e power integral f of x is minus 2 by x into dx, and that equals to e power, write minus 2 constant outside of the integral, that we get it as minus 2 into integral of 1 by x dx, and that equals to e power minus 2 integration of 1 by x is log x. So here that minus something m into log x, the formula is as log x power m. So similarly minus 2 into log x gives us log x power minus 2. So then here we can write it as e power log x power n, then that can be written as x power n. So here the power n is minus 2, then e power log x power minus 2, that gives us x power minus 2. X power minus 2 is nothing but 1 by x square. So this is the integrating factor Now we have to multiply this integrating factor to the question. So integrating factor is 1 by x square. Now multiply this integrating factor with the given question. So minus of x square plus y square plus 1 divided by x square into dx plus 2xy divided by x square into dy is equals to 0. So now write separately these terms. m1 is equals to, this is called m1. Now write the separate terms. So minus x square by x square and minus y square by x square and minus 1 by x square. This is m1, and n1 is equals to 2xy by x square. So x will be cancelled here, then we get as 2y by x. So now m1 is equals to, here we get minus 1 minus y square by x square and minus 1 by x square. Now we have to find out the dou m1 by dou y and dou n1 by dou x to check whether it is exact or not. So dou m1 by dou y is equals to dou by dou y of the first term, that is minus 1, minus differentiation of second term, that is y square by x square, minus differentiation of third term, that is 1 by x square, and that equals to constant differentiation is 0, and here 1 by x square is constant and y square differentiation is 2y, minus here 1 by x square differentiation becomes 0, and that gives us minus 2y by x square. Then similarly we have to find out the dou n1 by dou x, and that equals to dou by dou x of 2y by x. Now here 2y is constant, so 2y into dou y by dou y into 1 by x, and that equals to 2y of 1 by x differentiation is minus 1 by x square, and that equals to minus 2y by x square. Now it is exactly differential equation because dou m1 by dou y is equals to dou n1 by dou x. The both values are similar. So now we find out the general solution, that is integration of m1 dx plus integration of n1 dy is equals to c. Now in m1 y is constant and in n1 x term should not be present. So integration of minus 1 dx minus integration of y square by x square into dx minus integration of 1 by x square dx. So this is the integration of m1 plus integration of n1, that is integration of 2y by x into dy is equals to c. So minus 1 dx is minus x and minus here y square is constant and 1 by x square differentiation is minus 1 by, integration is minus 1 by x plus 1 by x, that is 1 by x square differentiation is 1 by minus 1 by x, minus into minus is plus, and here this value becomes 0 because x term is present in this. So plus 0 is equals to c. So furtherly we get minus x plus y square by x plus 1 by x is equals to c is the general solution for the given solution. And next video we will see the more problems on the method 3.